should we do this? Now, few things to take note is that if you see a summation which is like a linear, when this is linear, so like AR plus B, then it's an AP. Okay, this is a second page, a first page. Then if it's a constant, it's quite okay. So let me explain the constant first. So for example, if you see this first box, when it's a constant, it's also an AP lah actually, but what you see is something like that. So for example, if say I have summation of R equals to 2 to M, and this is like, say this is 3, okay, a constant. What does a constant mean? Means when R equals to 2 is 3, when R equals to 3 is 3, and 3, you just keep adding 3. Is that okay? Every time you iterate, right, your R don't replace with anything, but you just keep duplicating 3 every term until you get N. Okay, so this case here, what you get is a number of terms here. Now take note, just follow me very carefully when I like when I write NOT is the reason one. Don't go and write down N. So when you want to write down number of terms, especially so for sigma out notation, just write NOT. Okay, number of terms here is n minus 2 plus 1. This is n minus 1. Okay, so it's n minus 1. So in other words, if you want to find this general term, this will be n minus 1 multiplied by 3. Okay, formula for 3. So you every time, so it works for everything. So let's say k is a constant. Let's say you have got 5 to n plus 1. This is k. K is a constant. You know that this will be k plus k plus k until forever k. Constant. Then this one, number of terms here, is n plus 1 minus 5 plus 1, which is actually n minus 3. N minus 3. So this would be n minus 3 times k. Okay, so if it's a constant, you just duplicate yourself to the end of the series. Okay, so that's the idea there. So if it's a constant, you just, if this is n to 1 to n, then this is n times, so this is nk lah. So if it's a to b, this is this a to b, so the number of terms here is b minus a plus 1 times. So it's b. It's just that, the constant. Now, if it's a linear expression, so you are actually this one more appropriately AR plus B is an AP. Okay, this one will be an AP. Later I'll explain why, but you just remember, if you see summations like that, 3R minus 4. If you see summations like that, 1 minus R, and you see all these all linear one, right? These are all AP. Okay, you will be able to see lah. Essentially, if you you sub R1 to you list down the term one by one, you'll be able to see it's an AP. Okay, then same thing this one, number of terms is important. Later we will deal with that. This one looks very complicated, but actually it's not. You just slowly do it. It's not that difficult one. Okay, then for UR, if it's AR, if it's exponential for example, if you see things like that, this is GP. If you see things like that, this is a GP as well. Okay, so these are all GP terms here. When you see exponent, so means constant, then the R is above here. So this is a GP. Same thing. If you don't need to memorize, don't need to memorize. You just list them out. You can straight away see the pattern. Okay, so just to have an impression, you don't need to memorize anything. So we just see how we solve this part here. Now, this part here you can distribute, because each term here you can actually just distribute to each lah. Okay, if you want to. So I would say n is a constant. Take note, n is the constant. The running number is the R. Okay. So I would usually say keep the linear with the linear, but if you want to separate it out, also can, not an issue. Uh, this is a linear expression, right? So I'll just keep the linear, and then this one here is my GP. Okay. Uh, so let's try this one here. If I were to expand this will be 3nr plus n plus n r equals to 3r. Okay. Then this case here will be n summation of r equals to 3 and 3r plus 1. And this is that alright so far? Then what will be is, okay, if you're not sure, this one n, you just replace this when r is 3. R is 3 is 10. 10 is 13 when r is 2. When is this is, so this is r is 3. Just sub in 4. R is 5. The next one will be just 3 cube. Now, in exam, what you need to know is linear is just an AP, and then if it's exponential, is a GP. Okay, then if you don't need to like go and memorize, and you list it down, you can be able to see this one here is an AP. The D here is 3. The common difference, you just add by 3, right? All these just add by 3. Add by 3. My goodness. 3n. Okay, so you just keep adding by 3. The common difference here is 3. Okay. This is a GP. First term is what? 3 cube. Yeah, 27. Then the common ratio, okay, the R and the R, the common ratio, don't get confused. Common ratio is R. This R. You see, there are a lot of mathematicians. We are not very good with, we run out of alphabets very quick. The common ratio R here is, I'll put this as, maybe I'll put this common ratio. Common ratio R is 3. Okay, so don't get confused with this R. There you go. Right? R, right? It's R, right? Every time you multiply 3, right? Multiply by 3. Okay, great. Now this is where summation works. Oh, wait. Then the other thing is the number of terms of the series will be n minus 3 plus 1, which is n minus 2. So for both will be the same. Because they are the same, n minus 3 plus 1. The number of terms here is this. When we engage the formula, what I need you to see is this one here. That's why I say see this as NOT, because it will get very confusing very fast when you use the same alphabet. This is actually NOT over 2a plus NOT minus 1 times D. Okay, I'll just use n as an NOT. So similarly with the GP there, I'm going to use this as NOT. Okay, so when I say NOT, just do that. Alright, so usually I say NOT, meaning I just replace n with NOT. Okay, because NOT contains n, so it's quite jialat if you get confused. Now, AP, like I say, AB, how do we find the sum of AB? You just put NOT divided by 2, first term plus last term. We already explored why is it so. Because in primary school, this is what we actually do. We just take NOT divided by 2 first plus last. Given an AP, we just do that, right? Okay, so this case here, I'm going to use this formula here. This is actually just n minus 2 over 2, first term plus last term. So for sigma notation, it's very convenient because we know the first and the last. We just take the first and the last. I'm using this formula. Okay. Then for the GP, what you have is actually A arc. So 3 cube, 3 the above. NOT, which is what? N minus 2. Like that. In calculator. 27/2. And just leave it like that.